Let us consider some examples of working with midpoint. Please pause the video and work on this question before I begin the explanation independently. As always, we begin problem solving with text annotation. Identify keywords, what it is that you need to find, and restate given information. The fact that P is a midpoint of segment TR dictates some conditions that we must reflect on the diagram. Specifically, the fact that when we have a midpoint, it breaks the given segment into two congruent parts. So, point P is not just a point that guarantees partition of a segment. It is more than that. It is very specific. So you have to apply the definition of a midpoint that really should be in your head right now. A midpoint breaks a segment into two congruent segments. And those two segments, of course, will be halves of the original segment TR in our case. So once we establish that, I will begin my reasoning with the statement that since we have a midpoint, it is guaranteed that we will have two equal halves, and I will present it on my diagram. Then I will continue with identifying segments given in the conditions. At the same time, as I mark the diagram with that information, I will keep in mind which parts are halves and which segment is the whole. So TP would be a part, will be a half. So is PR. We will need to find at first the value of M. And I will begin working with the definition of a midpoint, naming one of the halves TP and the other PR, and writing that equation using symbols of geometry. Then I will continue with substituting the values from the diagram for each of these segments. And then we'll solve the equation. Now variable term is on both sides. Get rid of the smallest one, positive 3m. By subtracting 3m from both sides, this will result in a new equation equivalent to the original 2m minus 22 and positive 4 on the right side. Getting rid of negative 22 by adding 22 to both sides simplifies it to the equation 2m equals 26, which calls for division by 2 both sides and identifies then the value of m. Let us now find length PR. Find that length on your diagram. We could see that it is a half of a segment. So I will consider reasoning it as since PR is 3m plus 4, I don't want to skip this line so that there is no confusion with what I meant and how I got my result. The value of m now will be substituted from the previous conclusion, and then I'll verify my result with a calculator. 43 units since it is a length. Now let's see what else we can do in this situation. Question C, the length of TR. So what would be the length of TR? And first of all, let's make sure we understand where TR is. It is actually the entire segment. So you have some flexibility here in terms of how we can find it. We definitely now can apply the fact that the entire segment will equal to the sum of its parts. Unless you prefer to take your half multiplied by 2 and then receive your whole. That is also a possibility. I just don't want to go through this equation now. So my reasoning will be written as TR Bipartition of the segments is a sum of two parts. I will now describe these parts. First of them is TP, and the second is PR. The whole would be TR. So continue that with substitution. It requires that we notice once again the fact that we marked early in the beginning that these two portions of the segment are halves and they're congruent. So since we just found the value of PR, which is 43, it is then will be the same value that represents TP. So PR equals to 43 equals to TP. So in this case, then substitution will look like 43 plus 43. That would be the value, the length of TR, which we also express in units. Let us now consider a very similar but very different situation. You might notice that there is barely any difference in this text of the example. Yet that little subtle difference will make a world of difference in our solution. So to be specific, we really will need to start analyzing the situation. So we will start with annotation once again and restating the problem, the value of M. So since we have a segment TR, that's the first thing that we will show in our diagram. P is a midpoint, so the way the diagram appears now only shows that P is a point in between. So it is very important that we put these two hash marks to indicate that midpoint forms two congruent segments. Then we'll take the TP and mark it on the diagram. And then we'll take the TR, which in this case, notice, is the entire segment. And that is what makes this problem different from the previous example. In the previous example, you had two halves. Now it's one half and the whole. So we still will start with finding M. And the first reasoning, of course, is that although we recognize there is partition of a segment, we would need to be more precise than just this fact. We will need to recognize that midpoint means that we have two congruent segments. Those segments are two equal halves. But it is also important to remember that the same fact could be expressed slightly differently. Specifically, if we take a half twice, then the result will be the whole. And so if I abbreviate that situation, it will look like 2 times the half is the whole. Remembering all of that allows me to start my reasoning. So midpoint implies I'm thinking I will be using the second situation because this time my diagram indicates that I do have the whole and I don't really have anything for the other half. So I complete exactly that statement. Then I will continue with substitution into this equation. I'll use geometric terms first. So 2 times the half. Think which half you will take. There's nothing for this half. There is an expression for TP, so TP will go in. For the whole, be careful. Think first what you will write for the whole. It has to be TR and nothing else. Now I'll continue with substituting algebraic values. So the expression on the left will look like 2 times the whole quantity that represents TP. So that would be 5m minus 22. And think about what will be on the right side. The quantity that represents TR, which is 3m plus 5. So observe this equation. Now it's algebraic skills that will help us find the answer. So let's observe and notice that we have parentheses on the left. Distributive property with the multiplier positive 2 will allow us to remove this parenthesis. So remember to multiply every term. It will be then 10m and minus 44. The right side will be without any change. Subtracting the smallest term with the variable, 3m, from both sides converts my equation into its equivalent. So it would be 7m minus 44, and the right side will have just positive 5. Now, I need to get rid of minus 44. Opposite operation will produce an equation 7m equals 49. So we have our first result for the m. Let's see what else we can do in this kind of a question. We probably can find one of the lengths. So specifically in this case, we'll try to find the length PR. Find it on the diagram. PR, notice, it is the other half. There is no expression for it, but you and I know that this mark means it is congruent and the length is the same as the length of TP. So, as part of our reasoning, we will say then it is true that since PR is congruent, therefore equal in measure to TP, we can use the expression 5m minus 22 to find the length of PR. And so at this point, the substitution of m will allow us to evaluate this expression and find the length of PR as 13 units. It is very important to realize that absolutely the same procedure would be appropriate in the case when this kind of a question is worded slightly differently. Specifically, if instead of the word P is midpoint of TR, there is a phrase that there is a bisector of some sort. Some line cuts through segment TR at point P, breaking it into two equal parts. That's what we call bisection, and that would be the subject of our next video.